To build contractors, we shall use the interval arithmetic. As an illustration, consider three intervals x, y, and z, and assume that these three variables are linked by the following equation: v equal to x plus y. So because of this, I will be able to contract this interval. For instance, I can see here that z cannot be equal to 10. Why? Because I cannot find x and y inside these intervals, so that z can be equal to 10. So what means to contract these three intervals? It means to build a contractor associated with this equation. So this equation corresponds to a set which is represented here by the red plane in the x, y, and z space. So an equation corresponds to a set, and a contractor associated to an equation corresponds to a contractor associated to a set. If I have a box, for instance, this box goes to infinity, but let me consider another box. Represented here. The intersection between this equation and this box will correspond here, for instance, to this area. To contract this box means to compute the box which encloses this intersection and which is, of course, included in the previous box. How can I compute it? The smallest box. I will use this equation, so z equal to x plus y implies, for instance, that v belongs to the previous domain, meaning infinity. I know this. But I also know that it should belong to the interval for x plus the interval for y. So minus infinity 5 plus minus infinity 4. If I add these two intervals, I will obtain minus infinity 9. When I will intersect these two intervals, I will obtain 6, 9. It means that I was able to contract this interval into 6, 9. Or equivalently, I made this contraction. I remove this. Okay. Oh, what I have done for z, I will have to do also for x and y. So let me do it for x. X is equal to z minus y. It means that x belongs first to the previous domain, minus infinity 5, but also to the domain for z. So I can take this one or this one, I will obtain the same result. Let me take this one, 6 infinity, minus the domain for y, minus infinity 4. I will apply here interval arithmetic, and this corresponds to 6 infinity plus minus 4 plus infinity, which corresponds to 2 infinity. I compute the intersection and I obtain 2, 5. it means that X has been contracted to 5. I can do also the same for Y, and I will obtain here 1, 4. And to do this, I just have to do a similar computation, except that I have to start with the equation y equal to z minus x, and to do a similar computation. Thus, from one box, I obtain the contracted box. I have thus used interval computation or interval arithmetic to compute a contractor. This interval, in this situation, will be idempotent and will be minimal also. Of course, if it is minimal, it is idempotent. Why it is minimal in this context? Because we have a theorem which states that if in my equation each variable occurs only once, as it is the case here, x occurs 1, y also, and z also, in such a situation, if I isolate each variable and using the interval computation illustrated here, then I will necessarily obtain an optimal contractor.